Hello and welcome, dear mathletes, once again to Mathlete Minds. As we continue our journey of CBSE Class 10 Mathematics, right now we are focusing on the topic of applications of pair of linear equations. This is the fifth video pertaining to the same, and in this particular video, we'll be discussing questions pertaining to distance, time, and speed. Now, what are the important things that we must keep in mind while taking up questions pertaining to distance, time, and speed? The first and foremost thing that we must talk about is distance and the relation between distance, speed, and time. Distance is always a product of speed and time. This speed can be obtained by dividing the total distance by the total time, and time can be obtained by dividing the total distance by the total speed. Very important thing again to be kept in mind is the units of distance, speed, and time. So until and unless they are similar, if the distance is given in kilometers and the time is given in kilometers per hour, then obviously you'll get, if the time is given in hours, obviously you'll get the speed in kilometers per hour. So that needs to be checked out. The units have to be kept in mind always. Secondly, the important aspect is the moving object, whatever be the moving object in these questions that we'll be solving, we'll be keeping the speeds of the moving objects uniform throughout the journey, throughout the motion. So let's take an example here. A man travels 600 km partly by train and partly by car. If he travels 400 km by train and the rest by car, it takes him 6 hours and 30 minutes. But if he travels 200 km by train and the rest by car, it takes him half an hour longer. Find the speed of the train and the car. So the total journey that is done by the person is of a distance of 600 km. But there are interruptions in the journey. In the first case, he starts his journey by train and covers a distance of 400 kilometers. Say at the point C, he switches over to the car and does the rest of the journey by car. In the second case, he starts again by train and he does only first 200 kilometers by train and the rest of the journey, that is 400 kilometers by car. So now we are supposed to find out the speed of the train and the car. So as I said, we'll be taking the speeds as uniform speeds. So let the speed of the train be x kilometer per hour. And the speed of the train and the car, let us take it as y kilometer per hour. Now, in the first case, let us take up the two cases separately. In the first case, it's covering a distance of 400 kilometer by train. The distance 400 kilometer by x kilometer per hour, that is 400 by x hours plus 200 by y hours, that is equal to 6 hours and 30 minutes, that is 13 by 2 hours. So if I take out 200 common from the from the first two terms, I'll be left here with 2 by x plus 1 by y is equal to 13 by 2. Dividing both sides by 200, I get here 2 by x plus 1 by y is equal to 13 by 400. So this is the first equation. The second equation in a similar pattern will be first part of the journey is by train 200 by x plus 400 by y is equal to, he takes half an hour longer. That means 6.5 plus half, that is 7 hours. So this becomes 7. Take out 200 common. So you are left with 1 by x plus 2 by y is equal to 7, which can be written as 1 by x plus 2 by y is equal to 7 by 200. Divide both the sides by 200. So the second equation is 1 by x plus 2 by y is equal to 7 by 200. Now if I want to solve it, we can use any of the methods for solution, but here will be using the method of elimination. All right, so I'll be multiplying the first equation by 2 so that I equate the coefficients of y. I want to eliminate y. So I'll multiply the first equation by 2. And the second equation I'll multiply only by 1 or keep it as it is. So if I multiply this by 2, I'll be getting over here 4 by x plus 2 by y is equal to 13 by 200. And the second equation, I'll keep it as it is. So this becomes 7 by 200. Now simply subtract the second equation from the changed first equation. This is the second equation. So subtracting, you change the signs. That also must be kept in mind. So 4 by x minus 1 by x is 3 by x. 13 minus 7, the denominators are same, that is 200. So 13 minus 7 is 6 by 200. So we get here x is equal to 3 into 200 by 6. That becomes, this becomes 2. This is equal to 100. So x is 100 kilometers per hour. 100 kilometers per hour. Now in order to calculate y, we can put the value of x in any one of this equation. So if I take here 2 by y, 1 by y, the first equation is 13 by 400 minus 2 by x. So we get here 13 by 400 minus 2 by 100. Right, 1 by y. So take the LCM 400. So this becomes 13 minus 8. So that is 5 by 400. So 1 by y is 5 by 400 is equal to 5 by 400. So we get here 80. So y is equal to 80 kilometers per hour. So these are the two speeds. The speed of the train is 100 kilometer per hour and the speed of the car is 80 kilometer per hour. Now moving on to the next type of questions. Here we have questions pertaining to movement of vehicles in same and opposite directions. So here we have, in the first case, two cars moving in opposite direction. And here we have two cars moving in the same direction. Now, the important thing is we will be discussing questions where the cars are starting simultaneously from 2 points. In the first case, they are moving in the opposite direction. And in the second case, they are moving in the same direction. So how do we frame the equation? So supposing we have two cars, one positioned at A and another positioned at B. The car at A has the speed of x kilometers per hour. The car at A has the speed of x kilometers per hour. And the car at B has a speed of y kilometers per hour. Assume. And the distance between them is a distance of d kilometers. Now, supposing they meet in t hours. So the distance traveled by the first car will be AC. They are meeting at the point C. So the distance traveled by the first car is AC and the distance traveled by the second car is BC. So if you look at the figure, AC plus BC is equal to the total distance AB. What is AC? AC will be equal to x kilometer per hour into t hours, that is xt. Similarly, BC will be y kilometers per hour into t. This is equal to the total distance. Here, AC is the distance traveled by the first car. In a similar pattern, supposing the car at A is starting at x kilometers per hour and the car at B is starting at y kilometers per hour. Now, A has traveled a distance AC, that is equal to xt in terms of speed and time. B has traveled a distance BC, which is equal to yt. So if you look at the figure carefully here, it is AC minus BC is equal to AB. So xt minus yt is equal to the distance AB, that is d. So these are the two cases over here. In opposite direction, you add the speed into time plus speed into time to get the distance between the two cars. Important thing here is the cars are starting simultaneously from the moving in the same and opposite directions. Now let's take a question to understand this. We have here two places which are at a distance of 80 kilometers apart. One car starts from the point A and the another car starts from point B. Now in the first case, they are moving in opposite direction and in the second case, they are moving in the same direction. The question says if they move in the same direction, they meet in 8 hours. That means to meet at the point C, they take a time of 8 hours. And if they move in opposite direction, they meet in 1 hour. So when they meet over here, they meet in 1 hour. So in order to frame the equation, here we have AC plus BC is equal to AB. So what is AC? AC, supposing we take the speed of the first car as x kilometer per hour, the time taken by them to meet at C is 1 hour. So what is the distance it has traveled in 1 hour? It has traveled x into 1 kilometer. Similarly, the car from B has traveled a distance of y into 1 kilometer, and that is the total distance 80. So we can rewrite this as x plus y is equal to 80, the first equation. Second equation, here you will see AC minus BC is equal to AB. Now the car from A has traveled a distance AC, and it has taken 8 hours. The speed we are taking as x kilometers per hour. So the distance traveled is x into 8, and the car from B has traveled a distance BC. So the distance traveled is y into 8. This is equal to 80. So 8x minus 8y is equal to 80, or x minus y is equal to 10. So this is the second equation. Now, putting the second equation below the first one, this is equal to 10. And adding the two equations, you get 2x is equal to 90. So x becomes equal to 45 kilometer per hour. That is, the speed of the first car is 45 kilometer per hour. So the speed of the second car y will be 80 minus 45, that is 35 kilometers per hour. So that is how we need to frame these equations and solve the questions here. Moving on to the next question, a man walks a certain distance with a certain speed. If he walks 1 kilometer per hour faster, he takes 1 hour less. But if he walks 1 kilometer an hour slower, he takes 3 hours more. Find the distance covered by the man and his original speed of walking. So here we have a person walking at a particular speed. There are two different conditions that are arising here. Supposing he starts his journey at a speed originally be x kilometer per hour. And supposing he takes y hours to complete the entire distance that he has to travel, say it is d. So the speed into time, that is x into y, will be equal to d. This will be the first relation. Second, if he walks 1 kilometer per hour faster, he takes 1 hour less. Obvious. If we are moving at a higher speed, the time will be lesser. So if he travels at 1 kilometer per hour faster, he is taking 1 hour lesser. So this is the distance, that is xy. So here if you simplify this, you get xy minus x plus y minus 1 is equal to xy. Eliminate xy, so we are left with minus x plus y minus 1 is 0. In the second case, if he walks 1 kilometer an hour slower, that means x minus 1, he takes 3 hours more to cover the same distance d. So if you simplify this, you get here xy plus 3x minus y minus 3 is equal to xy. Xy gets cancelled, we are left with 3x minus y minus 3 is equal to 0. This is the first equation, this is the second equation. Rewrite the second below the first, so you get 3x minus y minus 3 is equal to 0. Add the two equations, so you get here 2x minus 4 is 0, which implies x is equal to 2 kilometer per hour. So his original speed of walking is 2 kilometers per hour. Now what about the original time that it takes to cover? So we can put the value in any one of the equation. From here, if I put it in 1, I'll get here y is equal to x plus 1. That is obviously 3 hours. So if he walks at 2 kilometer per hour, the total distance he covers in 3 hours, and the distance that he has traveled, distance will be speed into time, that is equal to 6 kilometers. So this is the solution of this question. Moving on to the next type of question, we have here objects moving in water. Like for example, a boat is moving in water. We have here two different cases that are arising, upstream and downstream. Now what is the meaning of upstream? When the boat or the water body, the object moving in water is going against the flow of water, that is called upstream. And when it goes with the flow of the water, it is called downstream. So now what happens in the case of upstream? When the boat is moving, say, against the flow of the water, then the speed of the boat is hampered, it is reduced, and the relative speed becomes x minus y kilometers per hour, where x is the speed of the boat and y is the speed of the water. But if it is going with the flow of the water, then the relative speed is enhanced and the relative speed becomes x plus y kilometers per hour. But here, x is always the speed of the object that is moving, that is, say, the boat or whatever is moving in the water. So then the relative speed becomes x minus y, and here the relative speed becomes x plus y. So let us see what are the type of questions that we get here. Now here we have a person rowing at the rate of 5 km per hour in still water takes thrice as much time in going 40 km upstream than 40 km downstream. So here the speed of the person who is rowing, that is of the boat, is given as 5 km per hour. So this x speed, that is the speed of the boat, is this. This is the speed of the boat. Now let us take the speed of the water, as equal to here y kilometers per hour. Y kilometers per hour. So now if he is going upstream, the relative speed will become 5 minus y. And if he is going downstream, the relative speed will become 5 plus y. The person is going 40 km upstream. So the time will be 40 by 5 minus y. And he's coming down 40 km downstream. So the time will be 40 by 5 plus y. Now the question says that he's taking 3 hours more, twice as much time in going 40 km upstream. That means this time, the time taken for going upstream, that is greater. This time, supposing it is T1, it is greater than T2. And how much it is greater? It is 3 times greater. So if I multiply this by 3, then I'll get here 40 by 5 minus y is equal to 3 times 40 by 5 plus y. So 40 and 40 will get cancelled out. We'll be left with, if we cross multiply the remaining terms, 15 minus 3y is equal to 5 plus y. So we get here 10 is equal to 4y. So y is equal to 2.5 kilometers per hour. So the speed of the stream is 2.5 kilometers per hour. The next question is, a motorboat can travel 30 km upstream and 28 km downstream in 7 hours. It can travel 21 km upstream and return in 5 hours. Find the speed of the boat in still water and the speed of the stream. So, in the first case, the boat is going 30 km upstream. So, let us take the speed of the boat as x km per hour and the speed of the water as y km per hour. This is the speed of the boat and this is the speed of the water. Now, going upstream, the relative speed will become x minus y. So 30 by x minus y plus 28 by x plus y, that is equal to 7 hours. And in the second case, it is 21 by x minus y plus 21 by x plus y is equal to 5 hours. So here what are we going to do? We are going to assume 1 by x minus y as u and 1 by x plus y as v. So we get here 30u plus 28v is equal to 7. Second equation becomes 21u plus 21v is equal to 5. Now you can choose a method of multiplying 30 by 21 or cross multiplying the coefficients and getting the solution. Another option is we can take the LCM of either 30 and 21 or 28 and 21 and take a multipliers also from there. So if we take the LCM of 30 and 21, the LCM of 30 and 21, this will be 3 tens, 3 sevens. So we get here 10, 7, 70. This is 210. In order to convert this 30 to 210, I need to multiply it by 7. And in order to convert 21 to 210, I need to multiply by 10. So I'm choosing my multipliers as 7 and 10. This is also another way of solving these question by elimination method. The first equation becomes 210u plus 28 into 7, that is 7856, and this becomes 196v is equal to 49. The second equation becomes 210u plus 210v is equal to 50. On subtracting these two equations, change the signs, u will get cancelled, so we are left with minus 14v is equal to minus 1. So v is equal to 1 by 14. Now let's take out the value of u. So if I put it over here in the second equation, I'll get here 21u is equal to 5 minus 21v. That is 5 minus 21 into 1 by 14. 7 twos, 7 threes. So we get here 21u is 10 minus 3, that is 7 by 2. So 7 threes. So u is equal to 1 by 6. This is u. Now v was 1 by x plus y. So x plus y is 14 and u is 1 by x minus y. X minus y is 6. Adding the two equations, we get this as 20. So x is 10 kilometers per hour. And y will be obviously 4 kilometers per hour, because x plus y is 14. So the speed of the boat is 10 kilometers per hour and the speed of the stream is 4 kilometers per hour. The next question is, A takes 3 hours more than B to walk a distance of 30 kilometers. But if he doubles his pace, he is ahead of B by 1.5 hours. Find the speeds of A and B. So there are two people walking and they are walking a distance of 30 kilometers. Now A's speed initially is less, so he takes 3 hours more than B to walk a distance of 30 kilometers. Supposing the time taken by A is T1 and the time taken by B is T2. So in the first case, T1 is equal to T2 plus 3. This is the first case. In the second case, when he doubles his pace, he is ahead of B by 1.5 hours. So in the second case, T1 is less than T2. T2 is greater. So whatever is the difference, like 1.5 hours, so that if we add, this is 1.5 hours over here, this will become equal to T2. So in the second case, we'll add 1.5 hours to T1 to get it equal to T2. Now what is T1? Let's take the distance and speed. Supposing the speed of the person A has a speed of x kilometer per hour and B has a speed of y kilometer per hour. So A takes 3 hours more than B to walk. So here if I put T1, I'll get here 30 by x is equal to 30 by y plus 3. Take out 3 common, so you're left with 10 by x is equal to 10 by y plus 1. Or we can write it as 10 by x minus 10 by y is equal to 1. Or 1 by x minus 1 by y is equal to 1 by 10. Now the second equation will be 30 by 2x, because he has doubled his speed, plus 3 by 2 is equal to 30 by y. Take out 3 common, so we are left with 10 by 2x plus half is equal to 10 by y. So this becomes, again, if I rewrite this as 10 by 2x minus 10 by y is equal to minus half. Take out 10 common, so 1 by 2x minus 1 by y is equal to minus 1 by 20. Now this is the first equation. This is the second equation. So we get over here 1 by x minus 1 by y is equal to 1 by 10, and 1 by 2x minus 1 by y is minus 1 by 20. Subtract. So the sign will change. This will get cancelled. So we are getting here 1 by x minus 1 by 2x. That is 2 minus 1 by 2x. That is 1 by 2x is equal to 1 by 10 plus 1 by 20. That is equal to 3 by 20. So we get here x as 10 by 3 kilometers per hour. So the speed of the first person is 10 by 3 kilometers per hour. Now moving on to calculate y over here. X is 10 by 3. So if I put it over here in the first equation or over here, 1 by x minus 1 by y is equal to 1 by 10. I'll get here 3 by 10 minus 1 by y is 1 by 10. So 3 by 10 minus 1 by 10 is 2 by 10 is 1 by y. So y is equal to 5 kilometers per hour. So y comes as 5 kilometers per hour. With that, we come to the end of this video. Hope you have understood. Hope you have liked the different types of questions, the different concepts that have been explained. Kindly like, share the video and subscribe to the channel for more of these videos. Thank you very much for watching.